Hi everyone. If you can believe it, this is going to be our second to last set of notes for this school year. This one's actually going to be pretty darn short. We're still going to be doing right triangle trig, which sine, cosine, and tangent, but now it's going to be within a word problem, and you're going to have to build a picture to be able to solve for whatever piece that it's looking for. And one of the things they normally throw in with word problems with right triangle trig is what's called an angle of elevation and an angle of depression. All right, these angles of the angle of elevation and angle of depression are created with a horizontal line. Okay, so you have to have a horizontal line in order to have an angle of depression or an angle of elevation. Okay, so let's start off with angle of elevation. When you think of the word elevation, it's like elevator, it means you're going up, right? So we're going to have an angle that goes up from a horizontal line. So if you look here, we have a horizontal line, and then the angle of elevation from that horizontal line is an angle that moves up, so it's right here. This is considered our angle of elevation. It's based on a horizontal line, and it's an angle that moves upward. Now, for an angle of depression, let me change my colors here real quick. An angle of depression still has to be based on a horizontal line. So if we look up here, we have an horizontal line. All right, but when you think about the word depression, that means going down. So from that horizontal line, we have an angle that moves downward, which you can see there's a arrow right there, but I'm going to put it over here just because it's easier to see. Depression means going down. So from this horizontal line, I have an angle that moves down. So this right here is your angle of depression. All right, so your angle of elevation, your angle of depression are based on a horizontal line. Okay, so here we go. What do you want to go with today? Oh, how about blue? Okay, so here's our first problem. We've got a 14-foot ladder. It's used to scale a 13-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? Okay, since we're in right triangle trig, every problem that we do is going to be based on a right triangle. So even before you read the problem, if you want, you can go ahead and just make yourself a right triangle. And then we'll figure out the pieces afterwards. If I had a ruler, this would look a lot better. Okay, so we have a right triangle. It says we have a 14-foot ladder is used to scale a 13-foot wall. Okay, well think about a wall. Which part of the triangle this is. A wall stands straight up, it's vertical. So this is our 13-foot wall. All right, and we have a 14-foot ladder. Now, if you think about a ladder, you're going to climb a ladder. It's not going to be straight up and down like a wall. It's going to be on an angle in order for you to climb up it. So this is our 14-foot ladder. It says, at what angle of elevation must the ladder be in order to reach the top of the wall? Okay, elevation means we need a horizontal line and we need an angle that moves up. Okay, well, here's our horizontal line. All right, and our elevation, like I said, it has to be one that goes up. So here's our angle that goes up. So this is what we're looking for, that angle of elevation. So let's just say that that's going to be x degrees. All right, now you're going to use everything you know about trig and right triangles to solve this. So you have to figure out which trig function do we have from the x degrees. All right, from x degrees, I've got the opposite side and I've got the hypotenuse. Opposite hypotenuse is sine. So the sine of x is equal to opposite, which is 13, over hypotenuse, which is 14. To get x by itself, we do inverse sine. So that's sine raised to the -1 of 13 over 14. And like you did in your last worksheet, you're going to put in 13 divided by 14 in your calculator. If you have my calculator, then you're going to hit second in the sine button to get inverse sine. And I guess we'll just round to the nearest tenth here. We're going to get x is approximately 68.2 degrees. Okay, so an angle of elevation is based on a horizontal line, and it's an angle that moves up from that horizontal line. Okay, we're going to do one more problem. All right, now before I even read this, you know what? We're in right triangle trig. I'm going to have a right triangle in order to solve this. Okay, so let me draw a triangle. Then we'll read through and figure out what it is that we're looking for. Okay, from the top of a vertical cliff 40 meters high. All right, we're at the top of a cliff. All right, the cliff is 40 meters high. So that means this is our 40 meters. All right, because we're up here at the top of the cliff. The angle of depression. Okay, here's where students make a mistake. Let's look back up here at this picture again. Angle of depression is based on a horizontal line, and it's an angle that goes down. Okay, so the only horizontal line that I have right now is the base. All right, but that's not where my angle of depression is. My angle of depression is going to be, let me get my color right here. Oops, that one. Is I'm going to have to draw in a horizontal line to work with, because the angle of depression is from a horizontal line and it goes down. Okay, so we're going to have to draw in our horizontal line, and this is going to be our angle of depression. It says the angle of depression of an object that is level with the base of the cliff is 34 degrees. Okay, the angle of depression is 34 degrees. That is this angle right here outside the triangle, because it has to be based on a horizontal line. All right, here's our horizontal line. The angle of depression has to go down. Okay, so the angle of depression is right here, and it's 34 degrees. Okay, how far is the object from the base of the cliff? All right, our object, the base of our cliff, here's the base of our cliff down here at the 90-degree angle, and it wants to know how far the object, here is our object over here, wants to know how far it is away from the base of the cliff. Okay, so we're actually going to need one other piece of information in order to set up our trig function. We need an angle inside of our triangle. Well, this angle up here, because we drew a horizontal line, is 90 degrees. So we can figure out this missing piece if we take 90 minus 34, and we end up with 56 degrees. So 56 goes here. The biggest mistake that students do is they put that 34-degree angle of depression where the 56 is. That is not where it's at. It has to be based on a horizontal line. Okay, so now we can figure out which trig function we have. Here we have 56. We're looking for the side opposite, and we have the side adjacent. Opposite, adjacent is tangent. So we're going to take tangent of 56 degrees is equal to opposite over adjacent. Opposite is x, adjacent is 40. All right, we're going to solve for x. We're going to multiply both sides by 40. And then we're going to use our calculator, and we're going to find out how much 40 tangent of 56 is. And that's going to be our x, and we'll just round it to the nearest tenth. So remember, if you're using my calculator, you work it backwards. Put in 56 tangent, and then multiply it times 40, and you should get x is approximately 59.3, and our measurement was meters. All right, you only have one more set of notes after this before our last trig test. I miss you guys, and I hope you and your families are doing well. And I look forward to seeing you all in the fall. Bye.